I missed what you said there. You were saying that tan inverse is an angle.
Always. Because tangent inverse is applied to a number and returns an angle. Because tangent is applied to an angle and returns a number. So tangent inverse of 12 over 5 is an angle. This whole thing.
Right, and that's how you got.
I apply tangent to both sides. Yes.
Okay.
Better?
Yeah, I was right.
Okay. Better? Other questions? Okay. Please choose one from 51 through 54. So what is left here is I want to show you two sets of formulas, which I will not ask you to remember. They will be given to you. And then I'd like to practice some identities, prove some identities. Any problem from 51 through 54? 54. So we want tangent twice theta. We are given cosine theta as being 3/5 and theta in 1. Evaluate each expression under the given conditions. So they want us to find what tangent twice theta equals to. Okay, here's how I start. Tangent twice theta equals what do you think? Remember what I said at the beginning? What is the key word in trig? That's in everywhere, but in trig and specifically, there is one other word. Keep it simple. I don't want to dig for formulas. I want sine twice theta over cosine twice theta. I'm not avoiding tangent twice theta. But I know sine and cosine. I know that I have no choice for sine. So I have to write 2 sine theta cosine theta. See, I'm thinking of using what I have and not trying to find more stuff. If I don't use cosine, then I'll have to find tangent. Right? So tangent twice theta is sine twice theta over cosine twice theta. Are we okay with that?
Yeah.
I know the formula for the top, I have no choice. But I have a choice for the bottom, and I'm given cosine. I will specifically choose the one that only has cosine in it. However, it doesn't really matter because I have no choice. Because of this formula, I have to find sine. So it really doesn't matter here which one you use. But I would prefer to cosine squared theta minus 1. So this is given, this is given. This is what I have to find and just plug it in and I'm done. So I have to find sine theta, knowing that cosine theta is 3/5 for theta in the first quadrant. How much is sine theta and how do I determine it? What is the identity that I have to write? And what is its sign? Since theta is in the first quadrant, what will be the sign of sine? Good. And then, what do I write? Right, because it's the square root of 1 minus 9 over 25. 25 minus 9 is 16, so this is indeed 4/5. Or you can say, forget about this. I can make my triangle. That's fine. That's fine. Whatever works for you. Good. So then I can continue here. I got the 2. I got the 4/5. And I got 3/5. And now the denominator is 2 multiplied by cosine squared, which is 9 over 25 and minus 1. And from here, we'll be able to simplify it. So 4 times 3 is 12, 12 times 2 is 24. The numerator is 24 over 25. And the denominator is 18 minus 25 over 25. Are we in agreement with this?
So what do you write right here? This
2 times 4 times 3 is 24. 1 times 5 times 5 is 25. 2 times 9 is 18. I have to change this into 25 over 25. So 18 minus 25.
No, you're still looking for sine theta? Or?
I'm looking for tangent twice theta, which is sine twice. Let's go back and make sure we understand this. So tangent twice theta is sine over cosine of twice theta. I replace this by 2 sine theta cosine theta. I replace this by 2 cosine squared minus 1. That's okay. I'll rather review. So I copied the 2. Instead of sine theta, I copied 4/5. Instead of cosine, I put 3/5. Then the denominator is 2. I have this, which is 3/5 squared, which is 9 over 25. And I copy -1. Are we in agreement here?
Mm-hmm.
And then 2 times 4 times 3 is 24. 1 times 5 times 5 is 25. I must multiply first 18 minus 25 over 25. So the two denominators will go away. The numerator is 24. The denominator is -7. So I have to write it as -24 over 7. Any questions? Any questions? Any questions?
Yeah,
Yes.
24 over is that right?
Yes, 18 minus 25 is -7.
Oh, okay, you did it. Yeah.
Good. So now let's practice one problem from each of the following two types. Changing a product to a sum, and changing, that's the first one. The second one, the order is not important. Changing a sum into a product. And those problems are 55 through 60. So please choose a product of any of the problems 55 through 60.
You
58. Okay, in 58 we have cosine 5x multiplied by cosine 3x. And the formulas are on the previous page. Is this a product or a sum? It's a product. So we want to change the product into a sum. There are 4 different formulas. And we want to identify that this is a cosine multiplied by a cosine. Which of these formulas is a cosine multiplied by a cosine? The third one. So I have 1/2 in front, brackets, cosine of the sum of the two angles plus cosine of the difference, the first angle minus the second angle. So 1/2 cosine of their sum. What is the sum of those two angles? Very good. Plus cosine of the difference of those two angles. That's it. Done. Now let's write the sum as a product. 61 through 60. That's it. Huge. I know right now it doesn't say much, right? It's huge. Because in calculus, to determine the integral of this, it takes 1 second. Right now it's huge. It's a huge property. Good. So 61 through 66. Please choose the reverse. The reverse is not as powerful.
You have the half.
Yeah.
Distribute that in. So
Yes. If you want, yes.
Cosine.
Yes.
Oh,
You cannot distribute it inside the function.
I see. Okay.
This is just 1/2 times f of x.
Right. Gotcha.
61 through 66, we're going backwards. We're given a sum and we want to change it into a product. Not as powerful, but important. Ready? Which one? Which one? It can be a sum is a difference also. Yes. Of two positive and a negative. It's still a sum. Yeah.
62.
62. We have sine x minus sine 4x. Let's go back to the formulas from before, the previous page. So it's a difference of two sines. Is there a formula that presents the difference of two sines on page 513? Yes. So it's twice cosine of the sum of the angles over 2, sine of the difference over 2. So 2 cosine of the sum of the angles over 2. What is the sum of these two angles? Over 2 multiplied by sine of the difference of the angles in the correct order, x minus 4x. You cannot reverse them. X minus 4x. What is that? Divided by 2. Now, I need to think for a second, dig deep and say, okay, is sine an odd function or an even function?
Sine is an odd function.
Awesome. Which means sine of negative 3x over 2 is the same with?
Negative sine x over 2.
That's it. Negative 2 cosine 5x over 2 sine 3x over 2. We use the property of the fact, that, sine negative 3x over 2 equals negative sine 3x over 2. Knowing that sine is an odd function. Do not consider that we factored out negative 1. We did not factor out negative 1 from inside sine. We only identified the fact that sine was an odd function and sine negative alpha is negative sine alpha. And we're done with this section, but I would like you to choose proving some identities, a couple of identities from 73 through 90. And we have a little bit of time for some trig equations. 73 through 90, identities. If you don't want to choose, I will. Okay, 78. In 78, we have 1 plus sine 2x over sine 2x. They say is 1 plus 1/2 secant x cosecant x. Remember, as I said when we looked at identities first time last week, I said sometimes we may be able to see a path from one to the other, but sometimes we may not be able to see a path. Staying simple in trig is always the best thing to do. Now, I do have an idea of what to do here. I could start here and change this into 1 over cosine and this into 1 over sine. I could. I could also start here, which I prefer, by the way. But what will I do here? What can I do here? Can I simplify this with this?
No.
Right, that's correct. Why? Because sine 2x is a term
Right.
out of these two terms, and sine 2x and at the bottom is a factor. Awesome, thank you. So then there is still something that I can do to the left-hand side. What will that be?
We split it in two.
Awesome. So I would like to start from the left-hand side, which is 1 plus sine 2x over sine 2x, and I will split it into two fractions. I can do that only or as long as the denominator is just one term. If the denominator is not one term, I cannot do this. It's not allowed. So the left one, I cannot change, but I will use the formula. What is the formula for sine twice x? The formula for twice sine x is twice sine x cosine x plus. But how much is sine twice x over sine twice x? 1. I peek. 1 is 1 plus, I do have the 1/2. So remember, 1 times 1 times 1 is the same with 1. So this is my first fraction, which is 1/2. This is another fraction, which is, and this is another fraction, which is, I'm done. I just have to rewrite it as 1 plus 1/2 secant x cosecant x, and right equals the right-hand side. So this was an example of an identity in which I used the double angle. Would you like to choose another, or we finish with trig equations? I do have a classwork for you, but I would like you to take it home and bring it back on Wednesday.
All right. I have one question.
Yes, please.
I never did an example where you do both at the same time. You said that,
True.
is that to be rare?
Quite.
Okay.
Yeah, that would be a little bit more involving.
Correct.
Yes. Would you like to choose another identity, or we come back to identities, but we move on now to trig equations?
Still equations.
We did a few. Okay, on page 523. So 7.4 and 7.5 are both trig equations. We are done with identities, no more identities, finished. Okay, trig equations. Say it again.
Till the test.
Till the test, yeah. 7.4, basic trig equations, and 7.5, a little bit more sophisticated ones. Okay, so let's start with something simple, like, let's say, 26 on page 523. Sine theta plus 1 equals 0. What is the variable here? The answer is the variable is an angle. It's theta. Perfect. Okay, so what would I have to do first to this trig equation? Of course, I have to solve for sine theta, which is sine theta equals -1. Now I have to think and ask myself this question. How many angles have sine -1? Well, the answer is infinite, but only one specific one.
Two. It's not two. I would say.
So let's think for a second. We measure sine where? On the x-axis or the y-axis?
Y-axis.
Right. So up here it's 1. Where will be negative 1?
3 pi.
Oh.
Right? So it's 1 here. It has to be 3 pi over 2 here.
Yeah.
Right. So I will say this is the only angle that has sine negative 1. So then theta equals 3 pi over 2. Correct?
Yeah.
Okay. I'm going to write plus, what is the period for sine? Very good. Multiplied by k. K, or n, in some books you'll find it k, in some books it doesn't matter. As long as I explain what k is, the letter is not important. Integer, meaning 0, plus or minus 1, plus or minus 2, and so on and so forth. Okay, what does this mean? It means this. There are infinitely many angles that end here and start on the x-axis as a standard angle. Here's one, 3 pi over 2. But it's also, when k is 1, is 3 pi over 2 plus 1 complete rotation.
Right.
Then when k is 2, 3 pi over 2 plus 2 complete rotations, and so on and so forth. What if k is negative 2? 3 pi over 2.
270 times 2, 3.
What if k is negative 3? So the correct answer is there is an infinitely many number of angles that end here and start here. Well, remember, there were the co-terminal angles, right? We discussed that on the first day of trig. However, one specific one. All the other ones don't give me more. I'm just saying there are infinitely many solutions. But I'm not giving you infinitely many different solutions. I'm giving you one, but there are infinitely many angles that have the same property. But it's only basically one, but infinitely many solutions, infinitely many angles. Okay, this was a simple one. Let's continue with 42.
So where it says list 6 specific solutions, it's asking for 6 of those angles.
Exactly. We created a general solution, and you can go with minus or plus, either way, and add to 3 pi over 2. Okay, 42. 2 sine squared theta minus sine theta minus 1 equals 0. And you can say, what is this? Well, I will have to say it's a trig equation, because the variable is an angle, and it's inside, I'm happy, it's inside one trig function, not 2 different trig functions. I don't have to work that hard, okay, to change one into the other. But I see that this is what type of function, or what type of equation also? Excellent. It's quadratic in sine. So if I can find a way to factor it, then I will have to dig deep and change this, use a substitution and use the quadratic formula and find the solutions for sine theta first. And then I will be in this situation. Sine theta equals blah, and I will go around the circle and write the solution for each one. Good. So is there a way of factoring? If you say, no, I don't remember, or it takes too long, then I'll have to change sine theta into t and use the quadratic formula. Can we factor this? Okay, ready?
Sine. Plus 1 minus 1.
Let's check. 2 sine squared, correct. Negative 2 sine theta plus sine theta. Negative sine theta, correct. And positive 1 times negative 1, negative 1. Awesome. So there are 2 options for sine theta. That's all I needed. Awesome. Well done. When my students answer, I feel that I make progress. So we don't have to go back and do other things before this. Good. So from here, I solve this at equal to 0. I move 1 divided by 2. Very good. And what is the other option? 1. Which of these two will have two different ones, and which one will have just one simple possibility? The negative 1/2, I have to work hard because I have to find angles that end where? Exactly. But what about sine theta equals 1? There is only one option. Well, infinitely many angles, but one option. Okay, so let's start with it. Very good. So let's start with the first one. Sine theta equals 1. There is only one option for theta equals plus k. But I have to write what k means. You either say k is an integer, and I'm happy with that, or you write k equals 0, plus or minus 1, plus or minus 2, dot, dot, dot. Okay, the one with sine theta equals negative 1/2 requires work. Sine theta equals negative 1/2. I have to go back to the unit circle. I know there, here's how I determine the one. So how long is this piece? From here till here. Correct, but negative 1, but you're right. So do we agree that this piece is negative 1/2?
Yes.
So right here I have to draw a horizontal line because sine theta is negative 1/2 is this piece. Okay, so then I know for sure that there is an angle that ends in the third quadrant and another angle that ends in the fourth quadrant. Both angles have the same terminal, both angles have the same reference angle, which is, thank you very much. So this piece, this angle in other words, is pi over 6, and this piece, or this angle, is pi over 6. So now, only when I have the reference angle, I can correctly identify the two angles whose sine is negative 1/2. Standard angle, of course. So sine theta equals negative 1/2 gives us two different thetas. The first theta is 180 plus 30, or I should say pi plus pi over 6. And this one is 2 pi, but minus pi over 6. See how easy it is now since you already have the knowledge. So pi plus pi over 6.
7 pi over 6.
Thank you very much. Plus.
Plus 2 pi. Yeah.
Very good. And the other one?
11 pi over 6 plus 2 pi times 3.
Wait, can you go over the, right, so sine negative 1/2, and then where'd you get the 7 pi over 6?
This one?
Yeah.
Okay. This is pi, but I have to add pi over 6 to it. So pi plus pi over 6. I have to change this into 6 pi over 6. So that's how I get 7 pi over 6. And for this one, I have 2 pi, but minus pi over 6. 6 times 2 is 12 minus 1. Better? Good. Other questions here? So feel free to choose anything you want from 39 through 56. They can get difficult. Yes, they can. And a lot of work. This is basically the end of chapter 7, but I still want to work on some trig equations from 7.5. So the department specifically decided to do this. And for example, they wanted us to stop at 53 in 7.4. It's up to you. Choose anything you want. From 39 through 56. But of course, I will not consider a super difficult problem. Not testing one problem or one knowledge. So let's choose one more.
Try 50.
50, very good. Awesome. Good pick. So 3, tangent cubed equals tangent. Okay, awesome problem. So this is a trig function because the variable is an angle. If I have the square root of x, then I'll say it's a radical equation because of the square root of x. But this is a trig equation, definitely, and the angle is the variable. Good. Secondly, I'm looking at the equation and I see tangent in it. And I say to myself, oops, tangent is a problem, like the square root, like rational functions, like what else we studied? Not yet. We didn't get to log functions yet. Okay, so I have to write a restriction for this. I didn't have any problems here because sine is not a function with restrictions, does not have vertical asymptotes. But tangent is a problem function.
Cosine can't be 0.
Correct. So what does this mean in the context of this problem? Whatever solutions I get, I'll have to make sure that I accept them only if their cosine is not 0. If their cosine is 0, I'll say, sorry, this may be a solution, but it's an extraneous solution. It doesn't work. So be very careful. When we look at the trig equation, first thing is we have to identify what, if it has more than one trig function. We hope not, because it gets difficult. And secondly, if the trig function in the equation is a function with problems, we have to state a restriction, like we did on the first day of classes with rational equations. I said, do not do anything, do not touch anything. You have to state restrictions first. The same thing here. I can't do anything before I make sure I made myself a note. Whatever will be accepted, only if its cosine of that angle is not 0. Okay, perfect. So now, what will you do? Remember, factor, simplify, and stay simple.
Simplify or stay simple.
Stay simple, true. However, I can work with tangent. I'm fine. How will I start, though? What will you do to this equation? I cannot. Of course, I have to have it set equal to 0. That's absolutely mandatory. I cannot simplify by tangent. You could say, divide both sides by tangent. I can't. Because if I do that, I may omit one solution. Because if tangent is 0, 0 equals 0. So that's a possibility. So I cannot do that. So yes, 3 tangent squared minus tangent theta. Now, oh, thank you. So then, what now? Factor, simplify, stay simple.
Now, first, now get back.
Ah, what do I factor out? Exactly. Remember, at some point in time, we wrote in our notes, never divide an equation, both sides of an equation, by something that has the variable in it. Somewhere in our notes from a long time ago. So, what now? What is left in parentheses?
3 tangents.
Yes,
Theta minus 1.
minus 1, correct? Awesome. Good. By the way, one more quick question. How many different solutions should I find? Yes, because the degree is 3, in other words. I shouldn't say degree for tangent. Degree is for polynomials. But I expect 3 different tangents. Good. Okay, very good. So for now I have two options. I have the option of tangent theta to be
0.
awesome, and I have the option for tangent squared theta to be, move 1, divide by 3.
There.
Very good. So let's solve the first one for tangent theta equals 0. When is tangent 0? Tangent is a ratio, sine over, when sine is 0. Where is sine 0 on the unit circle? At pi and
0.
0. So there where a tangent will be 0. So there are two options for theta. For tangent equals 0, there are two options for theta. Theta to be, yes, 0 plus, what's the period for tangent? Careful now.
Pi.
Yes, so it's pi k. And theta is the other one, which is plus, good. Now I'm here. So I have to solve the equation tangent. By the way, at 0 and pi, is cosine 0? If sine is 0, cosine cannot be 0 at the same. No, it's not. So these are safe. I checked against the restriction. Okay. So now I have tangent theta equals 1/3. What do I do to both sides next? Yes, awesome. I have to take the square root, apply the square root. So I have tangent theta equals, remember how many solutions we need. So you don't forget something very important. Okay. So I'll have the square root of 1 over the square root of 3, but I need to rationalize. Okay, so there are two possibilities here. Tangent theta is the square root of 3 over 3. And now you can say to me, but now I'm getting into trouble. You gave me your advice was not to mess with tangent. It's not a problem. How do I know what this is? Because for the small angle is 1/2 over the square root of 3 over 2. And when I flip, that's what I get. So let's write it. I have only two options for tangent, right? I either have, for pi over 6, I have 1/2 over the square root of 3 over 2. And when I copy the top and flip the bottom, I get 1 over the square root of 3, and this is what this is. So then I know theta. There is no point in checking the other one, because the other one will be the square root of 3 over 2 over 1/2 will be the square root of 3, which is not the case. So I know it's the small angle in a blink. So then I have, from here, we have two options. Theta to b and theta to b. Let's look at the unit circle. And once again, what is this angle? Good. So here's pi over 6. So this angle and this angle. And they must have the same reference angle, and they must have a tangent which is positive. So can anyone give us the first angle? So then plus. Very good, because the period for tangent is pi. And what is the other one? Knowing that this is pi, and this reference angle is how much again? Exactly. So pi plus pi over 6 is? Yes, you can condense. You can condense them. Pi over 6 plus pi k basically includes this. So here's how. You don't have to write the second one, right? So pi over 6 is here, but pi over 6 plus pi is here. Pi over 6 plus 2 pi is back here. Pi over 6 plus 3 pi is here. So I'm not saying that this is redundant. I'm saying you can condense both these two into this one. Last one, and I'll stop. 1 minute.
So is that only one solution then? Right, so they're basically the same.
Because I can condense them, but it's not exactly the same. right? Pi over 6 is not the same with 7 pi over
We'd be
6.
able to,
But you could condense them.
Yeah.
You could condense them into one solution. That will give you all possibilities for that. But I would say these are two different options.
Okay.
Because pi over 6 and 7 pi over 6 are two different angles. Okay, and the last one, we have tangent theta equals negative the square root of 3 over 3. And of course, we have two options, theta equals and theta equals. But I have now to look at the unit circle. And the reference angle still has to be pi over 6. So then this is the first angle, or one angle, and here's the other one. Both have the same reference angle, pi over 6. And what are they? Can anyone give us those two angles? Please work on this and bring it back on Wednesday.
5 pi over 6.
So it's pi minus pi over 6, right? Which is 5 pi over 6. Very good. You're right, you're right. So 5 pi over 6 plus pi k. And 2 pi minus pi over 6? 11 pi over 6 plus pi k. It's sufficient to write one time k equals 0 plus or minus 1 plus or minus 2, but somewhere you have to write it.